Here we go again. So, welcome back to my YouTube channel. So, for today's video, I will do a summary of chapter 4. So, network access. So, in this chapter, support our communication, the OSI model divides the function of a data network into layers. So, each layer works with a layer above and below to transmit data. So, every layer has a function. So, two layers of the OSI model are close tied that according to TCP/IP model, they are as essence one layer. So those two layers are data link layer and physical layer. So the sending device, it is the role of the data link layer to prepare data for transmission and control how that data access and physical media. However, the physical layer controls how the data is transmitted onto the physical media by encoding the binary digits that represent the data into signal. So it can convert in this chapter 4 can encoding the binary to represent the data into signal. So let's begin. So as you can see, here's we have 4 Ethernet switch and we have internet connection. So embedded wireless antenna, and then for figure 2 we have a connecting to the wired LAN. So connect your computer to the Ethernet port, so you can connect with you can connect with this because it has a 4 switches. As you can see, we have Ethernet port, and then this is the laptop. Then we have our interface card. So a wireless device will experience a degradation in performance based on its distance from wireless access point. The farther the device is from the access point, the weaker the wireless signal. See, it the farther the device from the access point, the weaker the wireless signal it receives. So, for example, your access point is in the house, but the wireless signal and you it is farther from your house. So the weak it means the signal is weaker. This this can mean less bandwidth or no wireless connection. So let's proceed to figure 2. So figure 2 shows the wireless range extender can use to generate the wireless signal to other parts of the house that are too far from the wireless access point. Alternatively, a wired connection will not degrade for performance. So as you can see, it is the wireless. So we have this wireless router, and we have the devices. So it is possible for you to connect easily. Let's proceed. So we have a physical layer, and OSI physical layer provides the means to transport the bits that make up the data link layer frame across the network media. So it means the transport bits that can make up a data link layer. So some bits produce the data link layer to across the network media. This layer accepts a complete complete frame from the data link layer and encodes it sends the signal that are transmitted into local media. The encoded bits that comprise a frame are received by either an end device or an intermediate device. So we have a physical layer media, we have copper cables, fiber optic, and wireless. So for copper cable, signal are patterned electrical pulses. So as you can see, here's the electrical signal, which is copper cable. We have fiber optic, is light pulse, and for wireless, it is microwave signals. So we have a physical layer standards. So here's physical layer standards are implemented in hardware and governed by many organizations including ISO, EIA, TIA, ITU, ANSI, and IEEE. So protocols can end operation of upper OSI layer are performed in software designed by software engineer and computer scientists. So physical layer consists of electronic circuitry, media, and connection developed by engineers. So physical layer, it consists of electronic circuitry and the connectors developed by engineers. So it appropriate that the standards governing this hardware are defined by the relevant electrical and communication engineer organization. So the physical layer standards, it can develop by the all some engineers. There are many different international and national organization regulatory the government. So let's proceed. So we have physical component. So the physical component are electronic hardware devices, media, and other connection that transmit carried signals to represent the bits. So physical components can transmit or carried to represent the bits. Hardware components such as NIC, interface and connection cable, materials and cable designs are all specific standards associated. So for encoding, line encoding is a method of converting a stream of data bits into predefined code. So from the word encoding, it is predefined as a code. So codes are grouping of bits used to provide a predictable pattern. So it can use for predictable pattern that can recognize both sender and the receiver. If if you use a pattern, it will recognize by the receiver and the sender. So as you can see, we have a pattern this. So what is bandwidth? So bandwidth is a capacity of medium to carry data. Digital bandwidth measures the amount of data that can flow from the one place to another a given amount of time. So bandwidth is typically measured in kilobits per second, megabytes per second, or gigabits per second. So bandwidth sometimes speed that bits travel, however, not accurate. So based on the um, in this definition, so bandwidth is a uh, medium to carry data, and then um, bandwidth has a measured in uh, we have unit of bandwidth. So we have a kilobit, megabits, and gigabit. And so we have a example of protocol. So LAN in one frame, which is LAN for local area network and wide area network frames. So each protocol performs media access control for specified layer to logical topologies. This means that a number of different network devices can act as nodes that operates on data link layer when implementing this protocol. So let's proceed. So as you can see, uh, from this we have a wireless frame connects with the HPP frame, and then we go to the HDLC router, and then with the frame relay, and then after that Ethernet frame, and we'll go to the end devices, which is the PC. So the data link layer protocol include the Ethernet, the wireless point-to-point protocol, HDLC, frame relay. So let's proceed. So again, here's the summary of chapter 4. So wired connection consists of copper media and fiber cable. There are three main types of copper media used in networking. So unshielded twisted pair UTP. So shielded twisted pair STP, and coaxial cable. UTP cabling is the most common copper networking media. So we have a optic fiber cable. It's very popular in the interconnecting infrastructure. So here in this, so among the different implementation of the data link layer protocol, there are different methods of controlling access to the media. These media access control techniques define if how those are shared. The actual media access control media use depends on topology and the media sharing. So LAN and WAN topologies can be physical or logical. So LAN and WAN can be physical or logical. So this is the end of my videos, the summary of chapter 4. I hope you enjoy it, and thank you for watching.